All right, so how far did we get, or how far did the thing fly? Remember, you can't use this thing, right? All right, so let's go ahead and try to figure out first the initial velocity. So what is V naught? Okay, so remember, this is 128 feet per second times the cosine of 30 degrees, and then 128 times the sine of 30 degrees. And now you know what these numbers are. Right. So cosine of 30 is, of course, the square root of 3 over 2. So this will be 64 square root of 3. And then the sine is 1/2. So this is 64. All right. So that's a pretty simple expression. Right. Now, oh, yeah. Oh, I forgot to tell you something, huh? Oh, I'm sorry about that. The bat at this point here, the initial position is 0, 3. That's a pretty important piece of information. Well, I don't think it matters at the end, but let's say that the initial velocity, the initial position is 0, 3. So the x coordinate is 0, the y coordinate is 3, which means the bat was, the pitch was thrown at, or it was hit at 3 feet above the ground, okay? All right, so with that, we can try to go back to this problem. All right, so what do we get from this? Okay, we can go ahead and write down the answer because we worked out this in general, right? R of t is equal to this thing here, right? So what is this? It's going to be 64 square root of 3 t. And remember, the first x coordinate is 0, so then you don't add anything. Second one, this is negative 16 t squared plus this number, 64t, and then plus the y coordinate of the initial position, which is 3. Right? So this is just, you know, using what we worked hard in order to get, which is our general formula for an object, for the position function when an object is hit or thrown or launched up in air. All right, and so I'm sorry about not giving you this. If you didn't have this, that's okay. You can fix it. It really doesn't matter, I think, for this problem. And by the way, once you think you got it, you can check for it. You can check to make sure, like this is easy. R naught is simply 0 and 3, right? You can check that. You can check the velocity function, right? And you can find V of naught. And you can find the acceleration, and all of these things check out. So this is the correct answer. Let's find, so what do we need? If to check if it's home run or not, okay? We need to know at what point is this going to be at that point. So let's try to find the velocity first. Okay. What I was saying is that when x is equal to 350, right, you can figure out what that x is at this point, and then you can find y. Actually, let's try to do that first. Okay, so we would like to find the y value when x is equal to 350, right? All right, so what is that? Well, that's 64 square root of 3 times t is equal to 350. And so t is 350 divided by 64 square root of 3, right? And so you need to find that. Let's use a calculator and find this out. You will see that the answer is about 3.1574. This is in seconds. So about 3.15 seconds after the ball was hit, it's somewhere at the, at this point. Now the question is, what is at that t? What is the y value? Okay, well, y value is this. So it's negative 16 t squared plus 64 t plus 3. Evaluate this at t is equal to 3.1574. And this value, if you do this, and of course, if you didn't have that 3, you don't have this 3, so your answer will be just off by 3, which is not going to cause a problem, I don't think, because you can calculate this to be, let me see. Yeah, you can calculate this All right, so this is 45.56, right? And this is, of course, in feet. And so what this is saying is the thing is way up here. It's 4 times as tall as the fence. And so, yes, it's a home run. And again, it doesn't matter if it's, start with 3 or 0. If you didn't have any initial condition or an initial point of 0, 0, then it would have been 42 here. That's still going to clear the fence easily, and that's a home run either way. Okay, so the answer to this was yes, right? Now, what's the maximum height? Okay, so the maximum height is obtained when the second component of the velocity, which is the second component of the velocity, where is my velocity function? Well, we don't have the velocity function. Let's see, negative. So basically, you're taking the derivative of that. That's negative 32t plus 64. You want this to be equal to 0, right? Because that's when the vertical coordinate of the velocity is equal to 0, which means it stops going up and then starts to come down. T is exactly 2 in this case because the numbers are worked out so nicely. And so you plug in 2, and the y value at this point, okay, again, using the same formula as we just did about right here. This time you evaluate at 2.0, and that's going to give you the answer, and that's 67. Okay, so 67 feet, this is the maximum height that the baseball is going to reach on the way to become a home run. All right, and then how about the range? How far? So for this, you want the x coordinate to be equal to, the y coordinate to be equal to 0, right? So you want to set this equal to 0. Again, you have to have 3, otherwise, it sort of messes up. But anyway, if you want to set this equal to 0, now you can solve this by, graphing calculator, or you can use your favorite formula in your pre-calculus class or college algebra class or whatever. Negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So it's 2 times negative 16. And so that's going to be about 4.046. And then there's another one, negative 0.0463. Now, what is that one? Well, that's, because if you went back in time, there is a point where it would have hit the ground before the ball was hit. And so that's what's happening here. But of course, you don't count that, right? And so now the x coordinate of at this point t is what you need. The x coordinate is 64 square root of 3 times t evaluated at that t. Okay, so that's what you need. And if you plug this in, you get approximately 448.5 feet. Okay, that is a big home run, of course. And of course, this is all happening if there were no air. And so it's sort of meaningless. This is just theoretical, where you assume the air resistance is negligible. But that's how you can do these problems, okay, in a vacuum. All right, so I hope you, now you should be able to do pretty much all of your homework problems. There's an extra section of, or extra part of this video, which is going to use that vector valued functions worksheet. And that has to do with, remember I was talking about this thing here, that has to do with decomposing the velocity, the acceleration. So here's your velocity or the tangent vector. And your normal vector is like this, right? And neither of them is showing you the acceleration due to gravity, which is this one, okay? So how do you decompose A in the direction of t and in the direction of n? And that has many important applications in areas like physics and so on. So that's what the worksheet is about, all right? So I will come back to that worksheet, and then that should conclude this chapter, as well as section 3.4.